So good day everyone. We are the group 7 and today we will be presenting about the importance of hazard analysis and critical control points or short for HACCP. So what is HACCP? Okay. So HACCP stands for Hazard Analysis and Critical Control Points like I said earlier. It is a food safety system designed to prevent contamination by identifying and controlling possible hazards like biological or chemical during food production. It was also developed in 1959 by the Pillsbury Company for NASA to make sure that the astronauts' food was completely safe, and today it is now used worldwide and recommended by the Food and Agriculture Organization and the World Health Organization through the Codex Alimentarius. So the Codex Alimentarius, by the way, is like a set of international rules to keep the food safe and also high quality. So now let us proceed to the some of the key importance of HACCP. Okay, so first we have here the prevents foodborne illnesses. So here, HACCP have stopped food from making people sick by identifying risks early and controlling them before they cause contamination. So for example, we cook the meat to the correct temperature, a proper hand washing before food preparation, separating the raw and cooked food. Okay, and now for the second one, we have here the systematic and proactive. So here it focuses on preventing problems at every step of food production instead of only checking the final product. For example, checking food temperature during storage or monitoring cleanliness of equipment and inspecting raw ingredients before use. So for the third one, we have here the enhances consumer confidence. So here it shows customers that the food is safe, clean, and responsibly made, which helps build trust in the brand. For example, a clean kitchen that is visible to the customers, safety certifications displayed in stores, consistent food quality and taste. Fourth one, we have here the legal compliance. So here, HACCP has businesses meet food safety laws and regulations required in many countries. For example, passing the health inspections, following the government food safety standards, and also avoiding fines or business closures. So now the next importance of HACCP will be presented by Ms. Kapiri.
Now, for the fifth importance of HACCP is the cost-effective. So, ang cost-effective is to stop problems before they start. So you don't waste money on throwing out bad food, calling products back, or even having to close your business. For example, bakery store. Kung gumagamit sila ng HACCP, tinitingnan nila na ang kanilang imbakan ng harina ay tuyo at pest-free bago gamitin ito. Dahil maaaring makapasok ang mga bugs sa harina at maaaring makapag-produce sila ng tinapay na contaminated. Ito ang isa sa pinipigilan ng HACCP bago mangyari. Once na ito ay mapigilan, hindi ka nagsasaya ng pera dahil sa sirang pagkain. For the next one is the improved resource management. It sets clear standards and monitoring procedures, which reduce inefficiencies, minimize errors, and ensures better oversight of all process from raw material handling to final product delivery. For example, a canned fruit factory. HACCP sets clear steps for how much fruit to wash, how long to cook it, and how to store empty cans. This means they don't use more water than needed for washing. And don't let empty cans sit around getting dusty. Everything is planned out so they use their supplies and time efficiency. Now for the last one is the supports quality. Works with other food safety rules to make sure food is not just safe to eat, but also consistently good. For example, a milk processing plant. They already follow GMP, like keeping equipment clean and workers in proper uniforms. HACCP Ads check for things like temperature, making sure milk is heated just right to kill germs and keep its taste and nutrients. Together, these rules mean every batch of milk is safe and tastes consistent, so the customer know what to expect. Now let's move on to the 7 principles of HACCP. Now for the first principle is conduct hazard analysis. Before making food, a business must check for anything that could harm people, gaya ng germs, chemicals, or objects. Meron tayong tatlong types ng hazard. First one is the biological hazard. Ito yung mga tiny living things that can contaminate food. Madalas itong nanggagaling sa raw meat at poultry. For example, bacteria, viruses, and fungi. Now for the next hazard is the chemical hazard. Ito naman yung mga harmful substances. These chemicals can enter food but on purpose or by accident during different stages of food production. For example, lubricants and oil can leak from machinery into food products. Now for the last hazard is the physical hazard. Physical hazard are unwanted objects like glass, metal, or plastic that accidentally get into food and can cause injury or illness if someone eats them. For example, glass, wood, and metal. Now third for the second principle will be presented by Miss Sion.
For the principle 2, identify the critical control point. In food production, there are many steps such as receiving raw materials, washing, cooking, cooling, storing, and packaging. At each step, a food safety hazard, biological, chemical, or physical, may occur. A critical control point or CCP is a step where control is essential to prevent a hazard, eliminate a hazard, or reduce a hazard to a safe level. If control is lost at a CCP, the food may become unsafe and cause a foodborne illness. To decide whether a step is a CCP, a HACCP decision tree is used. The decision tree helps determine whether a hazard exists at that step, whether control measures are available, whether the step can eliminate or reduce the hazard, or whether a later step will control the hazard. If no later step can control the hazard, then that step is a CCP. Once a CCP is identified, critical limit must be set. Now, for the principle 3, establish critical limits for each critical control point. A critical control point or limit is a maximum or minimum value that must be met to ensure food safety at a CCP. It clearly separates acceptable or safe food from unacceptable or unsafe food. Critical limit must be measurable such as temperature, time, pH, or weight, based on science or regulations, clearly defined and documented. Critical limits are important because they are clearly distinguish a safe food from unsafe food, provide measurable standards for food safety, help workers know exactly when control is lost, allow quick corrective actions, ensures compliance with food safety laws and standards. For example, time and temperature requires a thermal processes. Time and temperature are critical limits because harmful microorganisms are destroyed only when food is heated to a specific temperature for a specific time. Minimum internal cooking temperature. This is a lower critical limit. A food must reach at least minimum internal temperature to kill harmful bacteria present inside the food. Time allowed for cooling to a specific temperature. After cooking, food must be cooled quickly. Slow cooling allows bacteria to multiply rapidly in the danger zone. 5 degrees Celsius to 60 degrees Celsius. Maximum number and size of physical contaminants. This is an upper critical limit. Physical hazard such as metal, glass, or stones must not exceed acceptable levels to avoid injury. Maximum levels of chemicals residues. Chemical hazards such as pesticides, cleaning agents, or food additives can be toxic if present in high amounts. Critical limits ensures they remain within safe levels. If a critical limit is not met, immediately corrective actions must be taken. There are two types of critical limit, which is the upper critical limit and the lower critical limit. The upper critical limit is a value that must not be exceeded. For example, maximum chemical residue allowed or maximum storage temperature. The second one is the lower critical limit, a value that must be reached or exceeded. For example, minimum cooling temperature or minimum heating time. Now for the principle 4, establish monitoring procedures. Monitoring means regularly checking and measuring what's happening at a critical control point or CCP to make sure the process is under control and within critical limits. The purpose of monitoring are to check if the system is working properly, detect problems early before food becomes unsafe, provide written records as proof that food safety is controlled. For example, thermometers. Thermometers are used to monitor cooking, cooling, chilling, freezing, and storage temperatures to ensure food reaches or stays within critical limits. Clocks. Clocks or timers are used to ensure food is cooked, cooled, or held for the required durations is as specified in a critical limits. Scales. Scales are used to monitor ingredients, quantities, and chemicals concentrations to prevent overuse or underuse that could cause safety issues. pH meters. pH meters are used to monitor the acidity level of foods to control microbial growth, especially in fermented or acidified foods. Water activity meters. Water activity meters determine how much water is available for microbial growth. Lower water activity limits the growth of bacteria, yeast, and mold. And lastly, chemical analytical equipment. These instruments are used to identify and quantify chemical residues such as pesticides, cleaning agents, allergens, or additives to ensure they are within safe limits. Now, for the last presenter would be discussed by Kira.
So, Principle 5 is about establishing corrective actions. This principle involves developing predetermined steps that must be taken when monitoring at a critical control points. It indicates a loss of control when a critical limit is not met. So, in this part, you're establishing corrective action on the product that you are making. As an example of it, when you're, pag nagbe-bake ka, example nito is pag nagbe-bake ako ng cookies and hindi na met yung expected na temperature. Here. You set the oven to 160 Celsius but the oven thermometer shows it only reach 140 Celsius, too low. So, turn off the oven and let the cookies bake longer until the correct temperature is reached. And if the cookies look fine and reach the right temperature, they are okay to eat. If not, throw them out. Principle 6. Establishing verification procedures. The proving that the system actually works, checking the checkers. Example, calibration, testing the digital sensor to ensure they are reading 121 Celsius correctly. Taking finish scan, keeping it in a warm room for 10 days, and checking for spoilage. Principle 7. establishing record keeping and documentation, creating a legal paper trail. If it isn't documented, it never happened. Example, maintaining a file of a digital heat chart, the batch numbers, the calibration logs, and the stop training records. These are the essential for government audits. The principle 5 is about corrective action or intervention. What this is the what ifs. Kung ano yung mga gagawin natin pag may mali sa isang product or having a plan B. Sa principle 6 naman, it's about verification. Paano natin mapuprove na nagwo-work yung mga ginawa nating steps para ma-prevent ang isang problem. And yung principle 7 is all about the records. Dito naman makikita yung evidence. So yung hazard analysis and critical control point is not book on shelf. It is living process. It turns food safety from an invisible hope into measurable scientific certainty. So in conclusion, hazard analysis and critical control points is a science-based proactive system that shifts the focus of food safety from testing for errors to preventing them. By systematically applying its 7 principles, food businesses can identify potential risks and control them at the most critical stages of production. Thank you for listening to our presentation. That's all for today.